sometime in the next few decades, humans will leave this planet to live in another world.
That means that some people in our life can be the first Martians. How about that?
We're finding out a lot about how to explore Mars in our station. Over 1,000 people from over 40 countries have actually participated in one crew or another.
It's the grandest adventure I could possibly imagine. That is, for me, the most important reason why we should pursue the establishment of life on Mars.
If we go to Mars in our time, 200 years from now, there'll be new branches of human civilization on Mars.
Welcome. We are live. Hey, welcome to Red Planet Live. I am your host, Ron Craig, and today is our 5th episode. And my guest today is Professor Jim Bell. Jim Bell is Professor of Astronomy and Planetary Science in the School of Earth and Space Exploration at Arizona State University, ASU. He's a past president and member of the board of the Planetary Society. Jim is what we're going to refer to him today, is heavily involved in NASA solar system exploration missions like those of the Mars Rover Spirit, Opportunity, Curiosity, and most recently, of course, is Perseverance, which is currently tasked with searching for signs of life on the surface of Mars. And in 2011, Professor Bell received the Carl Sagan Medal for Excellence in Public Communication from the American Astronomical Society. He has also authored a number of popular science and photography books. You might have seen a lot of those. So Postcards from Mars, Mars 3D, Moon 3D, The Space Book, The Interstellar Age, The Earth Book, and Hubble Legacy, 30 Years of Images and Discoveries. And next month, his new book, Discovering Mars, which he actually co-wrote with planetary historian Bill Sheehan, will be released and available for order. So what we're going to do is we're going to bring on Jim and welcome him to the show.
Hey, Ron.
Hey, Jim. Hey, how's it going?
See you, man. Thanks for having me on. I really appreciate it.
Oh, man, it's really a pleasure, a huge pleasure and privilege of mine to actually have you on the show. It's just amazing. So what I'd like to do is we kind of want to jump in. So I was thinking now in terms of what you're actually involved in. So I'm going to pull up here one of my little templates just to kind of make things look cool. So in terms of looking at your mission you are obviously leading the Mastcam Z. No, you have to correct me. I'm in Canada, so if I said Z, you can lay into me and say
we have some Canadians on our team, and they say Mastcam Z, so it's all good. It's fine. Yeah.
It's funny. I practiced that like 6 times before you came on. I said Z, 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 and that comes out Z. I mean, I can't beat 40 years of conditioning.
No worries.
So welcome. And so what I really wanted to kind of talk about today is, you have been involved in so many missions and so many things from over the course of your career, from past, present, and of course, going into the future. You've also actually spoken at the Mars Society conferences and conventions as well in the past, which is amazing. And your talks there have been actually fantastic. And just to kind of do a little side, is that our Mars Virtual Conference actually is coming up on October 14th to 17th. So it's going to be a virtual conference. It's actually free to join, free to register. So go to marssociety.org and sign up today. And, it's been extremely successful, and we would love everybody out there to actually join us today. So marssociety.org, you'll see, and sign up. So Jim, I think, maybe we can just jump right in. I obviously, I want to be respectful of your time and you're busy. So I was thinking, I wanted to actually showcase if we jump right in and we take a look at, let's say, Mastcam, in terms of that mission that's currently on Perseverance. Now, I think Mastcam, you're also on Curiosity as well, is it not?
So there's a Mastcam on the Curiosity rover, and that is a pair of cameras. One is wide angle, one is telephoto. And Mike Malin from Malin Space Science Systems is the PI of that. I'm one of the deputy PIs. And that's, of course, it's all 3,254 that Curiosity is in, landing back in 2012. Spectacular mission. You've seen, hopefully, some of the incredible pictures of the mountainous terrain the rover's been driving around in. So that's Mastcam, a mast-mounted camera system. on Curiosity. Now, Perseverance, the new rover that just landed this year, is built from something like 90% spare parts out of Curiosity. That's how NASA fitted into the cost box to get a second rover in a decade. So that means it uses a spare of the same mast that Curiosity uses. So when NASA asked for new cameras, basically said to the world, hey, propose to us new cameras. Everybody knew what the volume constraint was. Those cameras had to fit on that same mast. And so we work with, at ASU, we work very closely with our colleagues at Mail and Space Science in San Diego. And we proposed a modified version of Mastcam that zooms, instead of a fixed wide angle and a fixed telephoto like Curiosity's Mastcam Z is a pair of matched zoom cameras, so we can have wide angle stereo all the way to telephoto stereo, just perfectly matched on the same mast. So we get 360 degrees of azimuth rotation, plus 90, minus 90 in elevation. So it's an evolution of the Mastcam on Curiosity, the Mastcam Z on Perseverance.
Well, that's amazing. One thing I think that, when I first was looking at the 3D images that was coming back, I think a lot of people had the same kind of misnomer in terms of there's actually something else there that are taking selfies, because they were saying, here's Perseverance doing a selfie. And, and the thing is that because of 3D camera technology, it really looks like there's actually another instrument or another person or something there that's actually standing in the distance that's taking a picture of. Yeah. So how does that technology work? Because
I'm with you, man. It baffles me a little bit, but then here's a simple experiment you can do to convince yourself of what's going on. People take selfies of themselves all the time, right? And so you're holding your camera, right? You hold it up and you're like this. Your arm is out there.
Yep.
Right? And you take the picture.
I'm doing it.
And then you get a picture of yourself and you don't see the arm. Yep. You don't see your arm, right?
Yeah,
we do exactly the same thing with Curiosity and with Perseverance. There's a camera on the end of the arm. On Curiosity, it's called Molly. On Perseverance, it's called Watson, but it's actually the same camera system. Also, another Mail and Space Science Systems camera. That's out on the end of the arm. We put the arm out like you put your own arm out, and you take a bunch of selfies at different angles, and you cover your whole body, basically, with selfies. But you don't see the arm. It's the same thing.
Yeah. Now, I think the only difference that now, of course, there probably could be a software or firmware update that you can do on your phone. But if your phone could actually do both cameras at the exact same time, you could probably mimic of what's, I think people stay, we talk about this a lot actually on the show, is that a lot of the technology that people are using today has come to fruition because of the necessity in space. Your phone, a lot of what's in your phone is actually driven by what actually happened in space.
Yeah. GPS, right? GPS is a bunch of satellites that are orbiting the Earth. They're communicating with your phone all the time. Lots of the details of the integrated circuits and the communication technology with cell phones, cell towers. There's so much that has been strong of our technology, of our consumer electronics technology, that has been so strongly influenced by the space program over the past few decades. It's amazing.
Yeah, and it's actually a fairly quick and rapid turnaround when you think about it. I mean, it does take time to obviously to provision that for the retail or consumer space, or whether it's commercial space. But it's amazing that because I think the new technology that's going on the cameras now that was actually sent to Mars, I think is the LiDAR technology, which is just incredible doing for that terrain mapping, which I believe is in your camera as well.
It's not in Mastcam Z, but it has been used on other cameras, and of course we have a lot of, Perseverance has more cameras than any other robot sent into space, something like 25 if you count the helicopter cameras on Ingenuity, and many of them are actually not super high tech. They're almost off the shelf cameras used for the descent imaging systems and all that. Sent as somewhat of an experiment. Can we use low cost cameras for a very short period of time for a very focused job in a tough environment? And so my colleagues at JPL tested a whole bunch of these essentially off-the-shelf cameras, put them through vacuum chambers and shaking and shocking, and a small number of them survived. And those are the ones that got to fly all the way to Mars and take those. I mean, the parachute movie, the descent movie down the bridle. It was like, oh, it's just insane. Really amazing stuff.
Yeah, it's amazing, and of course these cameras, like you're saying, they weren't designed to be rugged. So when you buy a computer nowadays, you can actually go and say, hey, Dell, I want you to get me a computer that's designed for rugged operations and manufacturing, but of course these are cameras. You don't really hear about cameras actually being designed with that mandate. So yeah, I mean, I can understand why you had to go to the shelf and say, let's see who can be rugged.
Yeah. And the Mastcam Z and the Mastcam on Curiosity have a lot of very small optics inside with very tight tolerances and alignments, and everything has to work perfectly. The zoom slides along these rails that have to work perfectly. And so the vibration of a rocket launch, the shocks of the deployments that happen after launch, I mean, these are all huge risks to sensitive optic systems. So we had to test all that. Tested it in vacuum, tested it huge temperature swings that we expect in space or even on Mars. We tested the shocks, we tested the vibrations, and we appear to have passed our tests. So we're doing really well.
I would say
cameras are working great.
Yeah, I mean, you did so. I mean, it's brilliant. I mean, it's amazing. I mean, the whole mission has been a success. I mean, ingenuity.
Absolutely.
Is, I mean, which was, I think, only supposed to go a few times. I mean, I mean, talk about, outstanding success. I mean, everything with the quality of the images coming back from Mastcam, with everything. I mean, all the cameras are just performing admirable.
And some samples in the bag now, right? I mean,
there are
one atmospheric sample and 2 rock samples out of a total of somewhere between 20 and 40 that we're going to collect eventually over the entire course of the mission. And so super exciting to be drilling into these rocks, and not just drilling, but coring and collecting, these little pieces of rock that are about the size of a dry erase marker, and putting them in these little tubes. They're inside the rover right now. We're carrying them with us until we figure out where to place them so that this next mission later this decade can come and get them and bring them to an orbiter and bring them back to the Earth. So, I mean, a bunch of us are just super excited about not just seeing Mars through these robotic avatar eyes that we see Mars through right now. That's all we can do. But we can we'll actually be able to see those rocks, those soils, with our own eyes in the lab, maybe within a decade. Boy, wouldn't that be spectacular? Won't that be spectacular? Yeah.
Oh yeah, it's going to happen for sure. I know I see a lot of people talking about, especially in social media, where they're saying, we got to get those things back sooner rather than later. But I think, one thing that, when you're working in the space industry and you're doing missions like this, is that your patience is tested. These things don't just happen. You can't just throw a rocket up and send it to Mars tomorrow. There could be 20 or 30 years of actual preparation that has actually been in place. Because I think even the Curiosity Perseverance rover line, if I remember correctly, we are talking about 20 or 30 years of research, all building upon to make that possible. It doesn't just happen overnight. It is rigorous testing, rigorous testing.
Right, and both these current rovers trace their heritage to Spirit and Opportunity, which were, in the early part of the 21st century, and Spirit and Opportunity trace their heritage to Mars Pathfinder and Sojourner rover in the mid 1990s, right? And so, yes, it has been a long line. But look, I don't complain about it, Ron, because
No.
People who study the moon and Mars, we get fast missions compared to my colleagues who want to go to Jupiter, Saturn, Uranus, Neptune,
Yes.
Pluto, other planets out there. I mean, decades, of planning time, and then you get, one shot like Europa Clipper. It's like so much is resting on that because it's taken so long.
And it's happening.
The New Horizons probe to Pluto, taking 9 years to get out there just to travel at that so incredibly high speed. It's solar system is big, space is full of space. But studying Mars, the moon, Venus, near Earth asteroids, close to home, we're pretty lucky that the travel times are relatively short.
Yeah. And I think too that with the vastness of space, we say that off a lot. We say space is vast, but I don't think we can really comprehend. I mean, when you look at about the visible universe, which I think what is it about 48 to 50 billion light years across, that's a fairly decent size. I mean,
Decent.
galaxy.
Yeah.
It's a little bit. So it's people always talk about interstellar missions and things like that. We've got a little ways to go because even getting to Andromeda to get to Alpha Centauri, I think we're talking like 4.3 light years away. That's not a big number until you start really looking at how many how many miles or kilometers that is. That's substantial.
Yeah.
So
and
we're
yet,
not going to.
and yet there's plenty of people thinking about those kinds of missions and how we can become an interstellar species, not just interplanetary species. One step at a time, right? But still, it's great that there are folks thinking about that. The physics that would be needed, the generational starships, all that kind of fun stuff. It seems science fiction-y right now, but it's also, maybe something that is achievable. Maybe not in our lifetimes, but not too far from now.
I think everything kind of starts out at science fiction. I mean, how often have we seen everything that starts out, so many things that start out at science fiction actually become science fact? I mean, if you even look at like the movies Back to the Future, there's so much that's in that movie that they were thinking about and kind of, the artists were visualizing. Now look at what we have today. They're talking on their wrist. We can do that. My watch does that. So it's amazing that it's almost like we are setting ourselves.
I want a Mr. Fusion. I want a Mr. Fusion for my DeLorean. I don't have one of those yet. So.
Yeah, or the flux capacitor, right?
or a DeLorean, for that matter.
Yeah.
So
Yeah. So I'm just going to kind of go through just to see if we have any questions coming in. So, I mean, we have one. No, I don't want to get into. I know I mentioned before the show that we'll try to kind of avoid some of the conspiracy. And we'll debunk things as they come in as needed. But I had one question come in here that I just saw go past. Where, what are the chances that we actually can terraform Mars? I know that's probably not. Actually, that's probably within your realm. I mean. I don't know if that's something we really think about that much today, terraforming. But first, let's get there. Let's worry about that later. But what are your thoughts on that?
Well, I mean, we were just talking about science fiction, science fact. Right now, terraforming a planet is science fiction. We don't have the technology. We don't have the infrastructure. We don't have the time. We are engaged in an experiment right now, changing the climate of our own planet. And, even though we're doing our best to pump a ton of CO2 into the atmosphere, it's taking a while, right? It's taken the better part of a century and a half for that to really start taking off. Hopefully we can do something about it. That's important to know that it's happening. We've learned a lot about our own planetary climate from climates of Mars, Venus, other places in the solar system. So maybe we'll be smart enough to do something about it. But to dramatically change the climate of Mars from 1% of the Earth's atmospheric pressure for a planet that is 50% farther from the sun, and therefore receiving much, much less sunlight, is a massive technological undertaking that we just don't really know how to do. It's even arguable whether there's enough resources there to do the job. People have talked about, well, if you evaporate the CO2 ice caps, maybe release that CO2 in the atmosphere. Some colleagues of mine have predicted that there actually isn't enough CO2 to make much of a dent in it. So how do we do that? Do we have to process the regolith in some way and extract oxygen? Hope that there's more CO2 or water ice underground than we think. Bring CO2 and other greenhouse gases in by crashing a comet into Mars. Okay, now we're really talking about science fiction, right? I mean, so right now it's kind of a dream, right?
Yep.
And then we have to step back and say, well, hang on, should we do that? Do we have a right to do that? What if there is indigenous life of some kind on Mars? We don't know that there isn't. That used to be science fiction to even think about there being, actual life, as we know it on Mars. But what the rovers and orbiters and other missions of the past 50 years have shown is that, there are habitable environments on Mars even today, and there were many more habitable environments on Mars a long time ago, early in the history of the planet. So it's not crazy to think about subterranean, sub-Aryan life on Mars. Maybe simple, single-celled, microbial, who knows? And that's partly why we explore that planet, partly why we want to bring samples back, because it's the clues, the indicators of that past life are likely to be, if it was there, are likely to be very subtle. Even if there's life there today, the indicators are likely to be extremely subtle, hard to find, and maybe not possible to find in place with the technology that we can send on these rovers and landers. So we have to bring the samples back and take them through the most sophisticated laboratories on our planet, and have 19 different groups try to validate the results, because of course, one of Carl Sagan's favorite things to say was that extraordinary claims require extraordinary evidence, right?
Yep.
And so if we do think there's evidence for life in some of these samples, that has got to be tested by many, many different independent groups before we'd be able to say, yay, verily, we've made a historic discovery.
Yeah, I mean, one thing that to bring up Carl Sagan, who is, I think, all of our, we all look to him obviously as the father of a lot of what we do. But one thing he also did mention in one of his comments was that if there is life on Mars, even if it's microbial, he actually felt that we shouldn't go there and actually try to inhabit it. From if I remember correctly from some of his statements. So so I think we might. I'm gonna I very rarely ever disagree with Carl Sagan, but for me personally, I don't feel that. I think we can coexist. I think we can coexist ethically, and but yeah, I'm sure I don't know what your opinion is on that one, but
yeah, I waffle back and forth between being optimistic and pessimistic about our species, depending on what's going on in the news.
Yeah.
But and you may be right. However, I think I would, and many of my colleagues would really like us to do the best possible job of searching for and potentially characterizing any evidence for indigenous life on Mars before we go and contaminate the place.
Yeah.
Right? Just by being there, we will contaminate. We've already contaminated the planet with the Soviet landers and other U.S. landers. Nothing is completely clean, right?
No.
We do the best we can, but there's always, some very small residual of the biota of Earth that make the trip. And so in a sense, we have already contaminated the planet, but locally, once people start being there in larger numbers, traveling around, doing field work, visiting some of the spectacular natural wonders as tourists, whatever, then the human imprint, the Earth biology imprint is going to be all over the place. And if we ever really want to know if life independently arose on Mars as opposed to was seeded from the Earth or vice versa, then we've got to do the best job we can of characterizing that environment and doing that search before this vanguard of human and terrestrial biology descends upon the red planet.
Yeah, and I think there's got to be some way that we find that we can do this, because if we were really stern and strict on that if there's life on a planet we can never go there, then that basically means that we can never leave. We can never go to any other planet, because any planet I think that is sustainable to us, let's say 80% of it. I don't think any planet will ever be. We were born here, we were built here. So, there's no planet that we can go to that. I think, it's kind of interesting. We see science fiction, we see Star Trek, we see people beaming down to planets and walking around without suits. In reality, that will probably never, ever happen, because we're never going to find a planet that is perfectly matched to our species. So,
I never say never, Ron. I never say never.
Yeah, okay, but most likely.
Okay. Just the sheer numbers of planets, tens of millions of Earth-like planets in the Milky Way galaxy alone. Some of them probably shirt-sleeve environment for us. I mean, the problem though is that they're so vastly far apart that the travel times to get to them. But I agree with your point. If we did adopt that philosophy, then we could search, we could explore and search, but then if we found some evidence for life, we'd have to leave.
Yeah.
Which
Look but not touch
would be very hard to do, right? I mean, that once that Pandora's box is open,
Okay.
it's not gonna be
So
closed.
we have a lot of questions coming in. So I'll just do a couple now. So we have actually, so Roger Nelson coming in. So if anything feels like it's getting into a political stance, feel free to say, no comment. But obviously, when you bring up other companies and what they're doing, there could be some, but, obviously we have, Roger Nelson here saying, do you agree with SpaceX's goal to make humans interplanetary via a private exploration program? I think that's a fairly safe one.
I agree with the concept of making humanity a multi-planet species. It means we're out there exploring. It means we're doing science. It means we're probably being tourists as well. It means that there's economic activity of planet Earth is spreading out into the entire solar system. So I do agree. I don't know if SpaceX has the right way to do it or not, but I think Elon Musk's heart is in the right place, in my opinion. And I know a bunch of folks at that company who are working hard to try to get that vision realized. Can we do it well? Can we avoid the mistakes in human expansion that we have repeatedly made on our own planet? The damage and carnage that we've caused to each other. Gosh, I hope we can avoid and learn from that. Again, I go through moments of optimism and moments of pessimism, depending on what's going on in the news. But ultimately, I am an optimist, and I do believe that that's part of the future that's coming.
Yeah, and I think, we always say often that we study history so that we don't actually risk, repeating some of the failures or travesties. But unfortunately, we seem to continue to do it. So we're obviously not studying history well enough in some cases. But, we
need to do better. We need to do better. Absolutely.
Yeah.
We can do better.
I mean, we have to.
This is a kind of a Roddenberry view, right? That the Roddenberry optimism is that we can do better. We can be a better species. We can figure out how to get along. We can figure out how to live off the sustainable resources of our world and the worlds and other worlds. And so, I grew up on Star Trek, not Battlestar and The Expanse. It's a little more dark and negative, maybe more realistic. I don't know, but I grew up with that Roddenberry optimism, and that's what I try to bring to all of this as well.
Yeah, I've had so many debates over my life where people talk, they always say, you were a Star Trek fan or a Star Wars fan. No, I like them both, but in reality, Star Wars, man, that is dark. They are blowing up planets left, right, and center. I mean, that's not a good place to be. There's a lot of bad going on there. Star Trek, at least, was very optimistic. They always had challenges, and maybe more so than they should have, but because they're always up against other species, they have, but still, Star Trek to me was kind of the pinnacle of what we can be. I mean, it really was a social experiment done in a virtual world, and I think that's something that I always see that we can aspire to as humankind, to say,
sure, why
can't we do that? I mean, look at that. I could live in that world and be quite content. So,
and it's all in that regard. It's been super exciting just the past month or two, right, to see this dawn of space tourism. Really, three different companies, in 3 different ways, sending people up, regular people, billionaire, okay, but
inspiration,
just regular people, and this is the future that's coming. It's taken a long time to get here, and it'll still take a long time to get to the thousands of people living on other planets kind of dreams of some folks. But you look back at 100 years ago, when it was just rich people flying in these crazy contraptions called airplanes, and the government seeded the nascent airline industry by having them deliver the mail, and they helped provide juicy contracts to obscure companies with names like United and TWA, and they used part of their profit to improve safety, reliability, lower cost, increase access to the atmosphere and the stratosphere for regular people. And that's the world we live in now, 100 years later. And exactly the same thing is happening right now with the government is helping to seed some, not all, but some of commercial space, right? And helping to lower the costs, and innovations like reusability that SpaceX and Blue are innovating on, and innovative techniques to get into suborbital and orbital flight from the companies like Virgin and others. It's just an amazing time. And give it 100 years, give it 200 years, and we will. Those people, our descendants, will be living in that future of, hey, honey, do you want to go to the moon for the weekend? Oh, I don't know. All right, let's go. Sure, let's go.
Talk about a honeymoon, right? So it's funny because Dr. Zubrin, actually, which he was on my first episode, and of course he's also the head of the Mars Society, which produces, of course, the show. He was saying that, of course, in the opening intro to the show, where if we start sending people to Mars in the 2030s, which is, of course, his estimate when he thinks that we're actually going to start getting people there, that in the next 100 years, there's going to be generations of people that are going to be living and born on Mars, where they're actually going to have their own society on there. Now, of course, what that looks like in terms of the political structure, society, culture, values, all that stuff are going to probably be very different than what we can probably think of today, because I think it's going to have to be, it's probably going to, have Earth seeding it in the beginning, my thoughts on this, and then it's going to eventually diverge, and it's going to actually become its own society, its own culture. And so that's what I would hope would happen, but I don't know.
Yeah. Well, and so will our descendants will diverge from us, right? Lower gravity environment, higher radiation environment. It's not entirely clear that we can successfully live on Mars long term. It's not clear that we can have babies on Mars, right? It's just we don't know. There's lots of unknowns, lots of work being done on the space station and other ways to do medical research to understand the long-term effects of the space environment. There'll be a bunch of testing and prototyping and practice on the moon. I firmly believe that the moon is our stepping stone to Mars. We need to learn how to go back into deep space, and we have this wonderful lifeboat right here called the moon. We're not done exploring the moon. We haven't explored the moon in person for more than 50 years. There's lots to do, great science to do there. There's technology development to do there. There's astronomy, geology, planetary science. There's tourism that's going to be on the moon, but mostly it's about learning how to live in the space environment again, and taking all of that experience that we rebuild with modern technology and then applying it to Mars and other destinations out there. So, we at Planetary Society, we talk a lot about moon to Mars. NASA talks about moon to Mars. We could go directly to Mars. I know Dr. Zubrin has for a long time been advocating Mars direct missions, and those will work if we decide as a nation to do that. Other nations may do that. SpaceX might do that. Who knows? I personally prefer a kind of a methodical approach, and I would love us to get that practice close to home. Rebuild a lot of what we had with Apollo, but with much more modern technology. So, but honestly, I want us to get out there. I want us to get back. I'm antsy for these new commercial missions that are going to go robotically back to the moon soon, scout out places for future human settlements. I'm antsy about getting the first people back to the moon. NASA astronauts, maybe they're SpaceX, maybe they'll be Chinese, who knows, right? But all of the above. Antsy to see that all move forward. And of course, getting those first crews out to Mars and getting human boots in the red dust is, I think all of us Mars nerds, right? We all share that goal. We all want to see that happen.
Yeah, it's amazing too, and I think one thing too, especially with what you're working on with the camera technology, I think with the communication delay that it takes, to go and actually have communication or imagery coming back. There is no such thing as real time communication to Mars. It's just not possible, and of course, but we do have near real time communication possible with the moon. I think what is it, half a second each way, so like a second round trip, which is basically you could, for the most part, is real-time communication. So we have that capability. And of course, it's also close enough, I think, that if there is some sort of an emergency or something we have to intervene,
Sure.
I mean, it is still far. We can't forget the moon is still pretty far, but we can get there within, as long as we had everything ready to go. We had a recovery mission ready, fueled up, ready to go off the launch pad. You can get there in a few days. Actually, you can get to the moon, actually, I believe, in less than a day. I think they've done in the past, but that was kind of a very special mission, going as fast as you could possibly go with that technology. But yeah, I mean, I think there's definitely benefits to, but we actually, one cool thing about, and we say this a lot because what comes up in a lot of conversations, it came up in actually a couple of my other shows, is people talk about, well, we have to worry about getting Earth fixed. We have to worry about what's happening here on Earth before we go here. But,
Totally agree.
to take that even further in the space context, we don't have to go to the moon, then go to Mars. We can also go to the moon and go to Mars. We could do things in parallel, because there could be, like you said, there's other people that may have an interest to do one or the other or both, is that we can do these things in parallel. We're never actually restricted to say it has to be this way. We can be flexible. We all have our preferences on how things should be. And, it's really just about being kind and, to me, about, respectful what everybody, wants to do. But I think,
well, I want to pick up on that point for a moment, and because obviously, it's expensive to have a space program. It's expensive to send people out into space. It's expensive to explore. It will be expensive to settle these other places. It will be costly in terms of dollars. It will be costly in terms of human lives. Let's not kid ourselves, right? It's dangerous. And we're going out into hostile environments, starting with the explosive rockets. And then you get there and it's a vacuum, and temperatures on the moon at 400 to minus 200, and then you go to Mars and there's radiation and no atmosphere to breathe and no accessible water unless you dig, blah, 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 blah. So, we shouldn't kid ourselves that this is very expensive. And so why don't we fix our own planet? What are we doing, right? You said it earlier, there's never going to be a replacement for the human race, in my opinion, and many others, besides the Earth. It's our home. It's where we're built for, literally, right? And but I look at it this way, right? With the engineering, technical, societal, cultural solutions that we will need to live sustainably for the long term as a species on this planet. Okay. All of that technology is also what we will need to live sustainably in space. And so all the research that's being done for alternate energy sources, for sustainability in terms of resources that are needed to keep us alive, air, water, food, all the research that's being done, that's being, in the space station, or thinking about people living on the moon, people living on Mars, other destinations in the solar system, all of that will come back to us on the Earth. Yep. All of that will apply to us on the Earth and help to make our planet a better place for us to live, help to make us better stewards of our planet. I really believe that. I told you before, I'm a ridiculous optimist. Okay, so there's some crazy optimism, but I think that the space program comes full circle, right? It's more than just GPS and Tang. Okay, it's a philosophy. It's a way of looking at ourselves as lonely inhabitants of a floating island that's unique as far as we can tell in our solar system. Maybe among the nearest stars, it could even be unique. There's probably other Earths elsewhere in the galaxy, but for the time being, this is it. This is our home. I think Carl Sagan called it our lifeboat, right? It's where we make our stand as a species.
Yep.
And part of the reason that we go out there and learn about these other places and learn how to live on these other places is for everybody else who's going to stay here.
Mm-hmm.
And I really believe that.
Yeah. It's almost like, you have this saying, it's not always in a good context, but, what goes around comes around. But I think, when it comes to our exploration and the technology, that's the thing that we're, I think, when it comes to these, NASA said it really well with Perseverance going when they actually came up with dare mighty things. These mighty things that we are daring to do really stretch us. They stretch us technically. They stretch our imaginations. They stretch every aspect of, I think, of humankind to say, the fact that we actually have, of course, you work very closely with this, we actually have robotic human technology millions of miles away on another planet, driving around.
Yes,
yeah.
Yes.
And
yes.
It's completely mind-blowing. I mean, it's very hard to fathom that this is actually the reality that we live in today.
Yeah. It's as close as we can get right now to exploring Mars ourselves. In fact, it is. People have debated me on this, but it is human exploration. We are projecting ourselves through these avatars. It's I try to be careful, especially talking with school kids or their teachers, and there's often it's like, oh, the rovers discovered this, or the rovers did that, and it's like, yeah, but they are machines. They are machines doing our bidding, right? We are programming them. We are guiding them. We are writing the software to help them make a limited number of decisions. But ultimately, it's human neurons that are driving the intelligence of these systems that we have all over the solar system. And so it's people, it's teams of people that it takes thousands of people to do these kinds of things. And so in a sense, robotic exploration is human exploration. And that's, I think it's important to point that out. I'll also, point out something else I learned as a student in school that, how is this tangible to us back here? What are some of the ways? And, it turned out that after the Viking missions landed in the 70s, and one of the things they did was, of course, they took pictures of all the landscape around them, took pictures of the atmosphere and the dust in the atmosphere and the way it reflected sunlight, made temperature measurements, and and noticed that when these dust storms happened and that dust was injected in the atmosphere, it got cold at the surface. And this wasn't necessarily intuitive. Wouldn't the dust be like a blanket that would help keep things warmer? Why would it get colder? And this was a puzzle. And one of my scientific mentors, a guy named Jim Pollack, who was Carl Sagan's first grad student, and others, Brian Toon, others, worked this out and figured out how dust injected into a planetary atmosphere can cool the surface. And they used the same model to figure out what would happen if the U.S. and the then USSR traded nuclear weapons and injected smoke and dust into the Earth's atmosphere. There would be no winner. Nobody could win, because the entire surface of the planet would be cooled to wintertime sub-freezing temperatures, and dramatically influence all life on our planet. Mm-hmm. And it's like, wow, hey, there's something pragmatic, right? If you can actually prove to these politicians that it's an unwinnable situation. It doesn't matter if you blow up all the cities, hey, we win, you lose, right? And so that was just, as a student, learning that was just a dramatic example of how you don't really know what we're going to learn about ourselves by exploring and learning about other worlds.
And maybe that we should probably listen to scientists more. Of course, that actually has been the creed for the last couple thousand years. But yeah, it's amazing the struggles of that scientists. But I think for every kind of doomsday scenario or that maybe has been averted, there's always been a scientist that has been advising somebody that actually convinced them to say maybe we shouldn't be launching those. So it's doing our due diligence, right?
I encourage people to listen to their inner scientist, right?
Yeah.
Think critically. Question things. Go work it out for yourself. Follow authoritative sources. Make a hypothesis and test it. And if it's wrong, change it. right? I mean, these are just hallmarks of the scientific method. That's what's got us to where we are with modern medicine, right? I mean, our lives are so enriched by modern medicine and modern technology because of this simple scientific method of way of thinking.
Yeah. So Jim, I wanted to give you a kind of a opportunity. Funny how, just actually, just when I was thinking of that, it's amazing the names of the missions that have gone to Mars: Curiosity, Perseverance, Opportunity. It's like, I mean, talk about picking the right words for the job at hand. I mean, it's just amazing how they're all inspirational. They're always inspirational words. But anyway, I'm going off topic and tangent, but I wanted to bring it up just as I'm saying the word.
It's all good. It's all good.
But I want to give you the opportunity to, because the mass cam imagery that comes back. I mean, these are extremely high resolution, extremely detailed, imagery. So I wanted to give you an opportunity. Do you actually have some images that you actually have available that you'd like to share, or maybe even showcase some of the sites and raw images?
Yeah. So I pulled up before we started. Let's see if I can do this here. I can share.
I can share. I can add your screen in there if you'd like.
Oh, there you go.
Yeah,
is that my screen?
That is your screen.
The screen
yes.
moving? Oh, okay.
That is your screen. Yeah.
I can't see them both. Sorry. So there's this great website. If you just Google Mars 2020 raw images, you'll get this URL here, and you can see all the data that come down from Perseverance rover from all of the cameras. Look at all these engineering cameras, science cameras, entry descent landing cameras, helicopter cameras, right? And so we can have a little fun here and just choose Mastcam Z. So what happens is, as soon as the data are downlinked to the Earth, they come to one of NASA's Deep Space Network antennas in Spain, Australia, or California. And then all those ones and zeros from the radio signal get relayed to the Jet Propulsion Lab in Pasadena and then turned back into the images. And they get kind of split up, and they come to the science team, and then they go to the web. In real time, automated, we have no control over it. So everybody can see the pictures as soon as we see the pictures. So here's some recent pictures that have come down just in the last few days. We actually just started a break. The Perseverance and Curiosity teams are on what's called a conjunction break, because it's superior conjunction. Mars is going not exactly behind the sun, but very close to behind the sun on the other side of the solar system right now. And when Mars gets that close to the sun, it disrupts radio communication. And so the management just says, okay, everybody take 3 weeks off. We're just going to let the rovers rest and downlink some data that they've collected earlier, or at least try to, with the kind of ratty radio signals. And but everybody gets like a 3-week respite from the grueling day-to-day operations. So we're seeing some images that were taken more than a couple of days ago from the Mastcam Z camera. So you can go in here and you can look at some. Just pick one here. Here's one from Sol 215, so just a couple of days ago. And you can download these yourself, and you can do that for all the cameras and just see what's coming in every day, just day after day, all these amazing images. And then we also have, I wanted to showcase, are you seeing my Mastcam Z website?
Yep. All your tabs are visible. So you
great.
shared your whole screen there.
Yeah. So this is mastcamz.asu.edu. This is at Arizona State. This is the public website for the Mastcam Z investigation. So we don't host the raw images here. JPL hosts those, but we do host a series of calibrated images, and we have some team favorites, right? So team members have picked their favorite images from the first 200 sols or so of the mission, some of them in stereo, some of them in enhanced color, some of them in true color. This is one of, I think I entered this one. This is just a beautiful shot of this place called Kodiak, that we got a early morning shot of sunlight on these just spectacular layered rocks. This is part of the delta in Jezero, and this is enhanced color. This isn't what our eyes would see. We've made the reds redder and the blues bluer. But to me, it was just so dramatic to see these. We weren't seeing these slopes because they were in shadow with the sun in the western sky. So we had to take this picture just after sunrise, with the sun coming from the east and low to illuminate these surfaces. And there's a paper coming out, our first peer-reviewed research paper as a team coming out next week in Science Magazine, all about what we're seeing in here and the implications for previous water flow in Jezero Crater. So check that out next week in Science Magazine. So that's kind of cool. And you could, but you can also, yeah, go ahead.
Yeah, I just wanted. So, can you explain why? Because even Hubble does this, and everything else that takes pictures typically takes these images in different color schemes. What are the benefit of doing versus true color that my eyes would see, as opposed to some false color? I mean, why do we do that? Why do we put the effort into actually altering the colors and making it so, let's say, for all better sense of a word, not quite realistic?
Yeah, it's a great question. And the answer is because our eyes are very limited. We see in a very small part of the spectrum, red, green, blue, right? But these digital sensors and cameras nowadays and spectrometers can see in the ultraviolet as well as the visible and the infrared. And different kinds of atoms and rocks and minerals reflect or emit light at different colors outside of what we can see in different ways. And so we basically can use these different color parts of the spectrum that the instruments can see that our eyes can't see as fingerprinting tools. So in the case of the rover cameras, certain kinds of rocks and minerals, like some iron oxides and some other kinds of volcanic iron-bearing rocks, will reflect light in the infrared differently than they do in the visible, and different minerals will reflect differently among those classes of minerals. And so we have some infrared filters, not heat infrared, but short, still reflected sunlight infrared, that can detect those patterns of color differences. And so we can use those to do a limited amount of sort of mineralogy with the cameras. They're cameras, they're not spectrometers, but we can sort of triage the scenery around us and find interesting color variations, including ultraviolet and infrared, and then tell our colleagues on the spectrometer team, hey, why don't you go point over to that? You're going to find something interesting, hopefully. So it's sort of because we can cover so much real estate around us, but the high resolution spectrometer instruments can only do little points here and there. So that's one reason. And Hubble does the same thing. Certain kinds of ions and elements emit at certain colors, but not in the visible light. So you want to get pictures of hydrogen emission or calcium emission or sodium emission or whatever. You pick filters that are just keying in on those specific colors. So I mentioned, we put the calibrated images on our website. We've got 26,000 of them there, and people can take these, and they've had some of the camera effects taken out. So they're more uniform. People are making mosaics out of these. And then one of my favorite places is our public submissions site. So there's a form you can submit an image for consideration. People are making their own panoramas, making their own anaglyphs, making their own VR movies out of what we're putting out there from Mastcam-Z and other cameras on the rover. So that's pretty cool. I invite people to check that out and submit for consideration your own work. That's a lot of fun. And then we have a great blog that team members put together, lots of stories, insider information about things that we're finding, cool experiences that some of our students are having. One of our colleagues on the team is an astrophysicist who's really into stereo imaging, founded a company in London called the London Stereoscopic Company. His name is Brian May. Can you see his picture here? Yep. And people may know it's also the same Brian May who was the lead guitarist from the rock band Queen. So we're super excited.
Oh, wow.
Brian, our team, he's become an astrophysicist and interested in stereo imaging, and he helps produce all kinds of great. He and his colleague Claudia Manzoni help produce all kinds of great stereo views, and they have a little Stereo Corner blog on our website. So anyway, just a great place to poke around. You can also learn lots more about the cameras themselves, about the instrument. And there's that picture you showed, and some tech specs, the science goals that we have, pictures of the instrument, more details and pointers on the mission in terms of what what we're doing with all the other instruments, pointers to the NASA website, the JPL website, all kinds of cool technical details about how the Mastcam-Zs work, including a cool animation about what's going on there inside the zoom lenses when we go from wide angle to telephoto, for example. So a lot of fun. I love our website, and a lot of people enjoy the information that we put out there.
And what's that URL again? I can also
mastcamz.asu.edu.
Okay.
mastcamz.asu.edu.
Okay, so
and you can find links to all of the JPL and NASA sites there as well, and learn lots about not just Perseverance, but Curiosity and the InSight lander mission, which is continuing on Mars, and the dozens of other spacecraft all over the solar system that NASA and other space agencies are running today.
Cool.
It's really just an incredible golden age of exploration of our solar system right now.
Yeah. So let's talk a little bit about the evolution of, let's say, the camera technology in terms of, where you started. I mean, we almost have to go, maybe a little delve back into the past. You've been at this for a little bit of time. So, in terms of, where it started and what does that evolution look like in terms of the quality, the technology, the components, if maybe take us back, when you first started, what did it look like then versus to what we see what we're getting back now. And it's just, you got to be kidding me. That's being sent across interstellar space.
Yeah, at least interplanetary space, at least.
Yeah. I was caught myself there.
It's all right. It's all good. Well, when I was a kid and the Viking landers landed, the pictures, the camera was just a couple of pixels and it was sending down these vertical strips, one strip at a time. It was like watching paint drip down the wall. It was incredibly slow. And now, of course, we have these megapixel digital cameras, and NASA and other space technology lags behind commercial technology, and for good reason, because you can't just take your phone and put it on a rocket and expect it to work in a super harsh radiation temperature, near vacuum, shock and vibe environment of space, right? So the technology has to be ruggedized, like you said before. It has to be tested out in a often high radiation environment. Missions that go to Jupiter and Europa, super high radiation compared to the Earth's environment. So these are dangerous places, and places where commercial electronics just won't work right. So it lags, and NASA especially also lags commercial technology just because of a fundamental conservatism that the agency has, which is appropriate in many circumstances. They're spending lots of taxpayer dollars to do this, and we want to guarantee that these things will work, right? And so you can't just say, okay, now I'm going to put a 40 megapixel camera on a spacecraft, even though one's never flown to space before, and I don't know if it'll fly in space. I don't know if it'll work right. Can't do that. It's too risky. It's too much of a risk to take with Congress and the taxpayers' money. And so you tend to make incremental improvements. Like Mastcam-Z was an incremental improvement over Mastcam on Curiosity. We added that zoom capability, tweaked the filters a little bit, improved the software a little bit, right? But incremental. Taking big leaps is hard. It's hard to do. Because you need a lot of testing to prove that it'll work if your risk posture is very intolerant to risk. Now, there's lots of entrepreneurial companies out there, small space startups and others that are willing to take more risk, and they're making more leaps, like landing your first stage booster on a crazy floating platform. I mean, who the heck is going to do that, right? Well, a small entrepreneurial company that is spending some of its own money, right, to do that. Not all, but some of its own money to do that. And, they're willing to take more risks. So it's really an exciting time to see lots of commercial space startups, especially entrepreneurial ones, take these risks. And, these landers, they're going to go to the moon soon in the next few years, that, they're going to be riskier, higher tech, riskier with a greater potential for reward. But the big missions like Perseverance, Curiosity, Europa Clipper, Galileo, Voyager, Cassini before that, generally much more conservative and careful and cautious with these larger expenses involved.
Yeah, it almost seems to be almost relative to the distance that you're setting. I think, if you're going to if you're going to go to low Earth orbit, you could probably take a little bit more risk, just because you're not going as far. But if you're going to send something, over to, let's say, Europa, which is going to take, I think, what is it, a 9-year trip, at least, so you
7
can't
or so,
just,
you
just can't. That's a long ways to go to say we shouldn't have sent the camera, and $1 billion later. It's so it definitely makes sense that, I mean, and I think that, to get back to your point about the moon, that I think that's one of the advantages of going to the moon first, is because you can test your concepts, you can test your processes, you can test your theories, your technology, and everything else that we're doing, even from the human perspective. And actually, that may save lives. That if we're going to just send somebody to Mars, and I think it all depends on how much risk you are willing to take. And I'm sure there are going to be a lot of people out there that would say, I'll go to Mars tomorrow. I will take that risk. You will find people that will probably put their hand up and are ready to go. And other people might be a little bit more conservative. At the end of the day, it's what you choose, right? And it's,
no, look, I would love to go, but I'll tell you what, I want to come back, man. I want to come back. Earth is my favorite planet. I've lived here most of my life. Most of my friends are from here. So, but I totally would love to take that trip someday.
Yeah. So I know we're getting close to the time. So what I want to do is give you the opportunity. You have authored a fair number of books, some amazing books, and you actually have a book coming out recently. Now, actually, I'm pretty sure that when we were talking initially, it was supposed to come out, I think, next month, but I believe you can order it today.
It's but it won't be officially released until I want to say October 12th or something. So a couple of weeks.
So I'm just going to bring.
You found it. It's called Discovering Mars. History of Observation and Exploration of the Red Planet. It's my colleague Bill Sheehan is the lead author, and I'm his co-author. Bill is a historian, also a psychologist. He's written a number of books on his own about the whole history of Mars and canals and seeing what we want to see, and a lot of the characters involved in the early history of Mars exploration. And he wrote a book back in the 90s called The Planet Mars. And I remember reading that when I was a student and getting an awful lot of information out of that, is a history of the early telescopic days of Mars exploration. And he wanted to, that was with the University of Arizona Press. This book is with the University of Arizona Press. And I think they must have approached him, or he approached them about updating the book. And, he's like, well, there's been this whole history of space exploration of Mars now. More than 50 years. In fact, this year is the 50th anniversary of the Mariner 9 mission, to the first mission to orbit Mars. That's in November. And so he reached out to me, and we talked, and we agreed to expand his original book to include an updated version of the entire history of telescopic exploration of Mars and the entire history of spacecraft exploration of Mars, up to the missions that have landed this year. And we think it's the first time that anyone's tried to capture that entire history of Mars exploration, from naked eye, telescopic, through spacecraft in one place. It's 700 something pages of one place. And we have some nice illustrations and all that. But it was just an enormous amount of fun to work with Bill. He's a fount of knowledge of the history of Mars, and a lot of work to try to summarize. I learned a whole bunch of stuff I hadn't known about many of the Soviet missions, for example, and so many attempts that they made to get to Mars, to beat the U.S. to Mars in the 60s. Comes out next month, and it's a tome. Like that thick, but for again, Mars nerds like us, hopefully it'll be a good read, and we've gotten some good reviews on it already. Kim Stanley Robinson wrote the foreword for us, which is just great. I mean, what a treat that was to have that visionary author take a look at our work and judge it well. It was great.
Yeah. No, that's amazing. Well, it's like an encyclopedia. You wrote an
Yeah,
encyclopedia, really.
when we got there's some appendices in there about timekeeping on Mars. Emily Lakdawala, who used to work for Planetary Society,
Yeah.
wrote a wonderful piece about Mars timekeeping as an appendix. How do we keep time on Mars? How do we reckon the seasons on Mars? Casey Dreyer from the Planetary Society wrote a wonderful piece about the cost of Mars missions historically over time. He did that for Apollo as well, and that was hugely popular on the web. He's done that for all the Mars missions as well, trying to estimate, what they have costed. And it's been a tiny fraction of the NASA budget actually for all of these missions that have gone. Something like 47 missions internationally, something like 18 to 20 attempts to land on the surface, going back to 1960, with now 10 successful landings. The Chinese Tianwen-1 mission and lander and rover were the 10th successful mission to land.
Yeah, we're getting pretty good at it now.
Of course, the Chinese were the first non-NASA mission to successfully land on Mars, and the Europeans will try with their launch next year again.
Yeah. Well, I love the new process where they're actually doing it with the sky crane. I mean, I think that's a winner, because I think one of the previous missions, of course, they were using the airbags, which is I'm just thinking, if I was actually on the planet as an indigenous native and seeing this airbag coming down, it's like okay, but it worked. It worked beautifully. I mean, it did.
What a sight that would be. Yeah.
But now, I mean, when you think about the whole, the sky crane and everything dropping the rover on the planet, I mean, that is right out of the scenes of a sci-fi movie. Something coming down and dropping something and leaving. It didn't go far, but it left. I mean, you sure you weren't shooting a Hollywood movie? Because that's pretty much what that would have looked like.
And we have the movies to prove that we did it, and that's incredible. So
okay, so I want to give you an opportunity then, as we wrap up, to kind of talk about what's in store for Jim Bell and ASU and future missions coming up. With what's coming down the road that you actually can share with us that maybe people might not know.
Well, of course, a lot of us in the Mars community have our eyes on Mars sample return, on getting those samples that are being collected right now by Perseverance and the Mars 2020 team, getting them back to the Earth, completing our mission really with that robust, detailed, authoritative assessment of the chemistry, the mineralogy, the atmospheric composition, and the biologic potential. And so that involves several future missions in collaboration with the European Space Agency. All the details are not worked out. The budgets are not approved, right? So this is going to be a long-term program, but NASA and ESA are collaborating on this, on a lander and a rover that would go get those samples potentially. And that lander carries its own little rocket that the samples get put into, and the rocket launches and goes into Mars orbit, and there's an orbiter waiting to collect those samples, that sample container, and bring it back to the Earth, maybe by 2031 or thereabouts.
Yeah.
It's possible that could happen. But so that's really Mars 2020 mission. The mission of Perseverance isn't done until we bring those samples back. So that's a big step. I mentioned the Europeans are sending their own rover, the Rosalind Franklin rover, as part of their ExoMars lander package with the Russians, and they're going to launch next year. We've got all these missions still operating: the Indian Space Agency operating an orbiter, the UAE operating an orbiter with a variety of instruments, the Europeans with orbiters there, NASA with the MRO, and the venerable Mars Odyssey still doing its job with science instrumentation and communications relay, the MAVEN orbiter. Gosh, who am I missing? The InSight lander is still on the surface, right? So continuing the operations and the exploration of the planet with the assets that are there. I don't know if humans to Mars is going to happen in the 2030s. It seems like, and I think Bob Zubrin would agree, humans to Mars has always been 20 years away. No matter when we think about it, right? And but the pieces of the puzzle are coming together, and additional additional capabilities coming from the outside, right?
Mhm.
Of course, the Chinese interested, and SpaceX interested,
Yep.
and both independent agencies, companies capable potentially of doing that. So it's not just NASA in this game anymore. Although, of course, NASA is my favorite space agency. I'll confess that.
No problem. Mine too.
Certainly would love to see NASA take the leadership on that and maybe make it an international effort. Let's collaborate. Let's go as a planet and explore this new world.
Well, I think cooperation. I mean, I think even because the Mars Society put out a tweet not long ago that Elon Musk himself retweeted, where they talked about that this has to be done in a cooperation. It has to be cooperative for this to really happen. Because I think there's certain things that just can't happen. SpaceX. Let's say they decide we want to go to Mars tomorrow, but there could be the need for certain technologies that they just don't actually have the capability to put there. Like people talk about needing a nuclear reactor on the surface of Mars, but commercial companies can't typically get a nuclear reactor and just move it there. So so you kind of have to have that cooperative. You need to have somebody overseeing it and actually keep it in. We do better together. We always will perform better together. I mean, I'm
with you on that one.
Competition does work. I think cooperation can work better. But
both models work, right?
Yeah.
We got to the moon on Apollo because of competition.
Yep.
And that, of course, we won that space race, and that completely revolutionized our scientific knowledge of the Earth-Moon system. And, the expectation is that we will, vault to new levels in our knowledge of Mars by exploring the place with people as well.
No, that's amazing. No, I mean, so I just want to thank you again. I think, obviously I want to be respectful of your time, and, I really appreciate you coming on and you're really sharing your thoughts about Mars and the missions and everything you've worked on. And, of course, there's so much more excitement in the future. And I think we're at a time now where, if you look at the Apollo era, now, of course, that's a bit maybe before I was able to, I wasn't alive then, but, the excitement and everything that was going on then, it really rocked the planet. Everybody was talking about it. And I think we're getting to a point now in the space program with everything with the commercial programs. And, there's a launch space launches were far and few between. Now there's a space launch every week.
Yeah. Sometimes multiple times per week. Yeah.
So it's just incredible. So I want to thank you. I mean, I really appreciate you coming on, and obviously, hopefully again we can have you on again in the future and maybe talk about some other things. You actually said something that really was interesting to me, is that you actually do a lot of you do some education with children. And so that's something that I actually want to look at doing a program or an episode in the near future where we actually go and maybe get some kids on and actually do something fun in that regard. So that'd be cool. Maybe we can invite you back for that.
Oh yeah. Space is just a great way to reach kids and STEM.
Yeah.
And, they're just naturally curious. They're naturally scientists and excited, just like we are as grown-ups, about rockets and space travel and planets and stuff like that. So yeah.
Okay. Well, Jim, thank you very much for your time. I really appreciate it. And everybody else who came in, I love the questions that came in. I really appreciate it. For the audience, for the guest, thanks to the Mars Society for producing the show. And as I mentioned before, our virtual conference is coming up from October 14th to 17th. So make sure that you get to the marssociety.org and you register. We want to see. It's a beautiful event. You're going to love it. So we want to see you there. And I will bid you adieu.
Thank you, Ron. Thanks for having me on. I appreciate it.
Thanks, Jim. Thank you very much. Okay, bye, everybody.
Sometime in the next few decades, humans will leave this planet to live in another world.
That means that some people in our life can be the first Martians. How about that?
We're finding out a lot about how to explore Mars in our station. Over 1,000 people from over 40 countries have actually participated in one crew or another.
It's the grandest adventure I could possibly imagine. That is, for me, the most important reason why we should pursue the establishment of life on Mars.
If we go to Mars in our time, 200 years from now, there'll be new branches of human civilization on Mars.